Good evening, children.
Good evening, ma'am.
Good evening, ma'am.
Good evening.
Good evening, ma'am.
Good evening. Good evening, children. I've shared my screen. Is it visible?
Yes, ma'am.
Very good.
Yes.
Yeah. So today's subtopic from this chapter, number systems, is exponents. Let's just recall the laws of exponents we have seen in standard 8. Don't write anything as of now. So you will receive an instruction from me when you have to start writing. So until then, we'll just discuss, understand. Don't write. Okay.
Okay.
Please, yeah. Please complete this identity. Complete this identity.
A power mn.
I mean, complete this law. Complete this law of exponents. A to the power
M plus
m plus n. Complete this one.
A to the power m.
The power my
Correct. And this one?
A to the power m and n.
Mn. Very good. This one?
A to b power m.
A into b, the whole power?
The whole
M square.
power m.
No. A into b, the whole power m. A into b, the whole power m.
M.
What about this?
A by b the whole power m. A by b the whole power m.
Very good. What's the value of this?
1.
Okay. Yeah, disable your mic. Yeah. This is the first question. Simplify 3 to the power 1 by 2 into 3 to the power 1 by 3. So here you see that the bases are same and it's multiplication. Somebody's mic is enabled. Please disable your mic. Yeah. So here you see that the bases are same and it's multiplication. So we need to add the powers. So the rule or the law we'll be using here to simplify this expression is a to the power m into a to the power n is equal to a to the power m plus n. Bases are same and it's multiplication. So we need to add the powers. So you can see here bases are same 3 and it's multiplication. So we'll have to add the powers. So it'll be 3 to the power 1 by 2 plus 1 by 3. Take the LCM and we get 3 to the power 5 by 6. Correct?
Yes, ma'am.
Yeah. In the next one, you see that the bases are different. Yeah, here you see that the bases are different, but they're raised to the same power. 2, 3. Bases are different. Base 2, base 3. Bases are different. It's multiplication, but both the bases are raised to the same power 5 by 8. So we use this law to simplify this expression. We use this law. What is the law? when bases are different, A, B, but raised to the same power, it should be multiplication. And when they're raised to the same power, the rule says multiply the bases and raise that to the same power m. A to the power m into b to the power m. What do we understand from this? Bases are different. A, B, bases are different. It's multiplication, but the powers are the same. So how do you simplify an expression like this? Multiply the bases and raise it to the same power m. So A into B, the whole power m. So applying this law here, we need to multiply the bases 2 into 3 and raise it to the same power 5 by 8. So 2 3s are 6, 6 to the power 5 by 8. Correct?
Yes, ma'am.
Yeah. So here the bases are same, 625, 625. The bases are same and it's multiplication. So we need to add the powers. A to the power m into a to the power n is equal to a to the power m plus n. All right, add the powers. So we have 625. The base is 625. Add the powers 0.16 plus 0.09. The sum of the powers is 0.25. And 0.25 can be written as 25 by 100. 625 can be written as 5 raised to the power 4. 5 into 5, 25. 25 into 5, 125. 125 into 5, 625. Now, how do you find out this? So 625 like this, divide by 5. See, you cannot divide by 2 or 3. It's not that we want to divide by 5. You cannot divide by, you try 2. It's not divisible by 2, right? Because it ends with 5. 625 is not divisible by 2. It's not divisible by 3 also. It's divisible by 5, 125 times. Again 5, 25 times. Again 5, 5 times. 5, 1s are. So we have 625 is equal to 5 raised to the power 4 because it's 5 into 5 into 5 into 5. So 5 raised to the power 4. So 625 is written as 5 to the power 4. 0.25 is 25 by 100. So 25 1s are, 25 4s are. So we have 5 to the power 4 into 1 by 4. Right? Now 4 and 4 gets cancelled. And the answer is 5. See, you know, when, okay, I think I didn't mention that here when we recall the laws. Oh yeah, we saw it here in the third one. So when the base is raised to many powers, you'll have to multiply the powers. See, if 2 is raised to the power 3, and it's again raised to the power, say, 5 by 6, the whole raised to the power, say, 2. So what do you do here? The base is 2. Now 2 is raised to the power 3, is further raised to the power 5 by 6, is further raised to the power 2. The base is 2. Multiply all the powers. So 3 into 5 by 6 into 2. Multiply all the powers. 3 into 5 by 6 into 2. Write the base 2 and multiply all the powers. So that's what we do here also. So here we have power 4. Here we have power 1 by 4. So multiply the powers. The base is 5, right? 5. And here power 4, power 1 by 4. Here 1 by 4. So multiply the powers. 4 into 1 by 4. 4 and 4 gets cancelled. So 5 to the power 1, which is 5. The rule is a to the power m into a to the power n is equal to a to the power m plus n. So 625 is the common base. Write that and add the powers. You get 0.25. 625 is 5 to the power 4. Using this procedure, 5 to the power 4. And 0.25 can be written as 25 by 100, which simplifies to 1 by 4. Now there are two powers, 4 and 1 by 4. So multiply the powers. The base is 5. 4 into 1 by 4. 4 here and here gets cancelled. So it's 5 to the power 1, which is 5. Correct?
Yes, ma'am.
Very good. Yeah. What about this? 2 to the power 55 into 2 to the power 70 minus 2 to the power 153 into 2 to the power minus 28. So here bases are same and it's multiplication. So we'll have to add the powers. 55 plus 70 minus, here again the bases are same, 2, 2, and it's multiplication. So we'll have to add the powers. So write the base 2 and add the powers. 153 plus minus 28. Or you can directly write 153 minus 28. You can directly write 153 minus 28. You'll have to add the powers. 153 plus minus 28. Next step, 55 plus 70 is 125 minus 2 to the power. Here also when you subtract 153 and 28, 5, 2, 1, 125. So it's like something minus the same thing. Don't find the value of 2 to the power 125. 2 into 2 into 2 into 2, 125 times is difficult in the sense it's so much time consuming. It's not easy to find that value. All right, so you don't have to find the value, but you see that whatever is here is removed. It's like 5 minus 5. Something minus the same thing is always 0. Something minus the same thing is 0. So 2 to the power 125 minus 2 to the power 125 is 0. Is 0. You can just cancel like this. It's like 5 minus 5, no, 0. Something minus the same thing is 0. So 2 to the power 125 minus 2 to the power 125. It's like plus 2 to the power 125 minus 2 to the power 125. 0. So the value of this expression is 0. Is this clear?
Yes, ma'am.
Yes, ma'am.
Very good.
Yes, ma'am.
Yeah, great.
Ma'am, I'm having a doubt, ma'am.
Yeah, please ask me. Yes.
Ma'am, what if we have 2 to the power 125 plus 2 to the power 125?
Plus.
Yes, ma'am.
Yeah. So 2 to the power 125 plus 2 to the power 125.
Yes.
So it will be 2 into, 2 into 2, because repeated addition is multiplication, right? Repeated addition is multiplication. So it will be 2 into 2 to the power 125. See, like I haven't finished. So it will be like 5 into 5. What is 5 into 5? Sorry, not 5 into 5. 5 plus 5. What's 5 plus 5? It's 2 into 5, right?
10, man.
10, but it's repeated addition is multiplication. So it will be 2 into 5, right?
Yes, ma'am. Yes, ma'am.
What is 5 plus
ma'am.
5 plus 5?
15, ma'am. 5 into 3.
15, ma'am.
3 times,
5 into
3 taken 5 times. So 3 into 5, right?
Yes, ma'am.
In the same way, this is repeated addition. 2 to the power 125 plus 2 to the power 125. Isn't it repeated addition? So then it is multiplication. Repeated addition is multiplication. So 2 to the power 125 is taken 2 times. So 2 into 2 to the power 125. So how do you simplify this further? Yes, you can
4
simplify
power
this further.
125.
No. Is this understood? Repeated addition is multiplication. So like you say 6 plus 6 is 2 into 6. 7 plus 7 is 2 into 7. So 2 to the power 125 plus the same thing, 2 to the power 125. Repeated addition is multiplication. So 2 into 2 to the power 125. Yeah, so what will be the next step? How do you simplify this further? It can be simplified. How do you do it? Are the bases the same?
Yes, ma'am.
Yes, ma'am.
And is it multiplication?
Yes, ma'am.
So what do? You add or you subtract the powers?
Add the power.
Add the powers.
You add the powers.
Add
What
the
is 2 to
powers.
the power 1 plus 125? Because
2 to the power 1.
that's 2 to the power 126. That's 2 to the power 126. If it was addition.
Yes, ma'am. Understood, ma'am.
Yeah, if. Got it. Let's do it again. I'll repeat this. So if the situation where 2 to the power 125 plus 2 to the power 125, then it's a repeated addition. It's something is taken 2 times, something is added to itself. So it is 2 into 2 to the power 125. Now this is nothing but 2 to the power 1. It's nothing but 2 to the power 1 into 2 to the power 125. So bases are same, 2, 2. And it's multiplication. So we need to add the powers. 1 plus 125. So 2 to the power 126. So here, 4th root of cube root of x square. 4th root of 4th root of cube root of x square. 4th root of cube root of x squared. So how do we simplify this? So to simplify this expression, it's convenient to express this in the exponential form. What you see is the radical form. The question is given in the radical form. Or we'll write it in the exponential form. So write this one as it is. See here, write this as it is. And 4th root in the exponential form is written as to the power 1 by 4. To the power 1 by 4. Other than the 4th root, disable your mic. Other than the 4th root, yeah. So this radical sign 4th root, that becomes to the power 1 by 4. The rest of the expression becomes the base. See, this one becomes to the power 1 by 4. The rest of it is written here as the base. Now again, okay, I shouldn't take it out from here. Now this cube root of becomes to the power 1 by 3. Don't write that, write the rest of it. So apart from cube root of 3, so cube root, what do you see here? Not cube root of 3, sorry. Apart from this cube root symbol, what do you see here? X square. So write that. And this cube root, this radical sign cube root becomes to the power 1 by 3. And this already that power 1 by 4.
Ma'am,
Yeah.
I can't understand that first step, ma'am.
No, I'll repeat it. See, I'll explain and I will mostly do it again. Then you can ask me.
Okay, ma'am.
Yeah, continue to listen. So now when the base is raised to many powers, we'll have to multiply the powers. When the base is raised to many powers, we'll have to multiply the powers. So multiply like this, and you can simplify. So this is x to the power 1 by 6. X to the power 1 by 6. So this is square root. This sign is said to be in the radical form. Radical form. Its exponential meaning is to the power 1 by 2. The meaning of this in the exponential form is power 1 by 3. The meaning of this in the exponential form is power 1 by 4. And so on. So if it's fifth root, then it is to the power 1 by 5. So here we have the expression fourth root of cube root of x square. Now, this radical sign, fourth root, this one becomes to the power 1 by 4. So this fourth root, you've written it as to the power 1 by 4. Now, apart from that, what do you have in this expression? Write the rest of it here in the bracket. So you have cube root of x square. That's the first step. You have to write this cube root of x square. Because this radical sign fourth root is written in the exponential form as 1 by 4 to the power 1 by 4. Next, cube root of. So this radical sign becomes to the power 1 by 3. To the power 1 by 3. So apart from that, what do you have in this expression? X square, write that. But there's already this power 1 by 4. So power 1 by 4. Now the base is x, but it is raised to multiple powers. So multiply all the powers and simplify if possible. Multiply the numerators. 1 into 1 into 1 is 1 by 3 2s are 6. So the answer is x to the power 1 by 6.
Can we write 6th root of x?
Yeah, you can also write a 6th root of x. Yes, Haridarshan, you can ask me now. I can repeat, or if you have a specific question, please ask me.
First step alone I can't understand.
First step alone, is it?
Yes, ma'am.
Okay. Let me write the question. See, fourth root of cube root of x square. So I'm saying this fourth root symbol becomes to the power 1 by 4. All right.
Yes, ma'am.
Now you should write the rest of it. Write this one in the bracket here.
Okay, ma'am.
Now this cube root, no? This becomes to the power 1 by 3.
Okay,
There's
ma'am.
already that power 1 by 4.
Yes, ma'am.
This is x square. You'll have to write it here as the base. Now multiply the powers. X to the power 2 into 1 by 3 into 1 by 4. Got it?
Okay, ma'am.
You can also write it as 6th root. Somebody asked me, no? You can write it as 6th root of x.
Okay, ma'am. Thank you, ma'am.
Yeah. Now all of you find the prime factors of 243. Do that. Don't write the question. Just use a rough notebook for today's class or a sheet of paper. Find the factors of 243. Let me see who's the first to answer this question.
Ma'am,
Hmm.
ma'am, I just joined. Can you tell me what happened till now?
Yeah, I've started the subtopic exponents of the same chapter, number systems, and we've completed 5 questions so far. You just continue listening, Lakshana. Yeah, you just continue listening. I'll help you. If supposing you're not able to follow, I'll help you. All right. Now the question now, the question now is find the factors of 243.
Ma'am, it is 3 to the power 5.
3 cube into 3 square.
Yeah,
3 to
3
the
cube
power?
into 3. 5.
5.
3 to the power 5. Yeah, that's all. 3 to the power 5. Correct. 381 times 3, 27 times 3 9s are 3 3s are 3 1s are. So 243 is equal to 3 to the power 5. All right. So Q, now we'll write, now we have in this expression, we have 3 parts. We have 3 parts here in this expression. We'll write every part in the exponential form. We see them in the radical form here. These 3 parts, we see them in the radical form. We'll express the 3 parts in the exponential form to simplify. So don't write. So Lakshana, the instruction is we are not taking down anything now. We're just discussing and trying to understand. I'll later give you the instruction when you can start writing. All right. Now write everything in the exponential form, children. How do you write cube root of 3 in the exponential form? 3 to the power 1 by 3 into 4th root of 3 in the exponential form.
3 to the power 1 by 4.
3 to the power 1 by 4.
Correct. And what is 243? 3 to the power 5, right? 3 to the power 5 and 12th root. So to the power 1 by 12, correct? 243 is 3 to the power 5. And 12th root, this radical sign 12th root, when written in the exponential form, is to the power 1 by 12. So now we have 3 to the power 1 by 3 into 3 to the power 1 by 4 into 3 to the power. You'll have to multiply the powers. 5 into 1 by 12. Multiply the powers. 5 into 1 by 12. So 5 by 12. So now what do you see here? The bases are same. 3, 3, 3 and its multiplication. So we'll have to add the powers using the law of exponents. When bases are same and its multiplication, add the powers. So 1 by 3 plus 1 by 4 plus 5 by 12. So that you can do. That you can do, right? So add the powers, LCM, and you get 12 by 12. So 12 and 12 cancel. So it's 3 to the power 1, which is 3. Yeah, any questions here?
No, ma'am.
So we write 243 as 3 to the power 5 and this 12th root is to the power 1 by 12. Here 3 to the power 1 by 4, 4th root becomes to the power 1 by 4. Cube root is to the power 1 by 3. And here we'll have to multiply the powers. 5 into 1 by 12, which is 5 by 12. 5 into 1 by 12. When the base is raised to many powers, multiply all the powers. So here the bases are same and it's multiplication. So add the powers. 1 by 3 plus 1 by 4 plus 5 by 12. LCM, we get 12 by 12. Cancels 3 to the power 1, which is 3. Yeah, well, if you find the factors of 250, see, you actually don't have to do this procedure, you can just use any multiplication tables. See, like you can write 250 as what? 25 into 10, right? 25 into 10. Just write it as a product of 2 composite numbers. Any 2 numbers, 2 composite or prime numbers, whatever. So 250, you can write it as 25 into 10. And what's 25? 5 into 5. And what's 10? 5 into 2. So these are the factors of 250. So 250 is equal to 2 into 5 into 5 into 5. That's it. That's exactly what you would get when you perform this procedure also. You get the same thing.
Ma'am, 5 power 4, ma'am.
No. 2 into 5 cubed.
Ma'am, 5 into 5.
250. 2 125 times, 5 25 times, 5 25, sorry, 5 5 times, and 5 1 0. So 250 is equal to 2 into 5 cubed, or 2 into 5 into 5 into 5. So I told you, you don't have to actually do this procedure. You can just write 250 as 25 into 10, and 25 is 5 into 5, and 10 is 5 into 2. So we have 250 is equal to 2 into 5 into 5 into 5. That's it. So like that, express all the numbers as a product of their prime factors. So see here 250. See this? This is the given question. So 250 is 2 into 5 into 5 into 5. 16 is 2 into 2 into 2 into 2. 54 is 2 into 3 into 3 into 3. That's the first step. Writing these numbers as the product of their prime factors. Writing the numbers here as a product of their prime factors is the first step. In the next step, now you can see the radical sign is cube root. So from 3 equal factors, 1 comes out because the numbers are under the cube root symbol. From 3 equal factors, 1 comes out. So from 3 5s, 1 5 comes out. So 1 5 comes out, and this 2 remains under the cube root, not square root, remains under the cube root. So from these 3 5s, 1 5 out, and this 2 remains under the cube root. Similarly here, of these 3 2s, 1 2 out. 1 2 comes out of the cube root. There's already a 7 there. There's already a 7. So you can see that 7. There's already a 7 in the question. So that's 7. And now from the cube root, from 3 2s, 1 2 out. So you can see that 1 2 out. 1 more 2 remains under the cube root. So you can see that here. Minus this 4, which is already there outside. And from the cube root, from 3 3s, 1 3 out. So you can see that 3 out here. And cube root of 2. Because this 2 remains under the cube root, not square root, cube root. From 3 equal factors, 1 comes out. Now this is 5 cube root of 2, 14 cube root of 2, 12 cube root of 2. It's like 5x plus 14x minus 12x. Just treat this as x. Just treat this as x. Which one is x? Treat this as x. This cube root of 2, no? Treat it as x. 5 cube root of 2. Treat that as x. 5x plus 14x minus 12x is 7x. 7x meaning 7 cube root of 2. 7 cube root of 2. See, this is multiplication. 7 into cube root of 2, which is nothing but 7 cube root of 2. This is the given question. First step is to write the numbers under the radical sign as a product of their primes. Product of their primes. That's the first step. Now from 3 equal primes, 1 comes out. So from 3 5s, 1 5 out. This 2 remains under the cube root. So cube root of 2. There's already a 7 here. So plus 7. From 3 2s, 1 2 out. And this 2 remains under the cube root. Minus 4, which is already out here. From 3 3s, 1 3 out. And this 2 remains under the cube root of 2. So now this is 14 and this is 12. 14 cube root of 2, 12 cube root of 2. So on simplifying this, so I said treat it as 5x plus 14x minus 12x. So you get 7x, which is 7 cube root of 2. Yeah, your questions? All right. Similar. This one is similar, children. Yeah, go through. Please go through the working. If you have a question, you can ask me. I'm not explaining this. I've done it in two ways.
Ma'am, I don't understand what you did in the second step of the first solution.
Yeah, which part?
The second step, ma'am. The
Fully.
5 square minus, yeah, that one.
How many fives under the square root?
4.
How many fives? Four fives. So
Yes, ma'am.
from 2 fives out of the square root. Okay, let me just write this one as square root of 5 into 5 into 5 into 5. So 4 fives under the square root. So from 2 fives, 1 5 out. Okay, 1 minute. If this is not clear, let me just work it here. So it is 625 is 5 into 5 into 5 into 5 minus 8 cube root of 125 is 5 into 5 into 5 plus 4th root of 81 is 3 into 3 into 3 into 3 plus 15. 5th root of 32 is 2 into 2 into 2 into 2 into 2. Now, the radical sign here is square root. So from 2 equal factors, one comes out. 2 equal factors. So from two fives, 1 5 out. From these 2 fives, 1 5 out. Minus 8 into. Now the radical sign here is cube root of. So from 3 equal factors or from 3 equal primes, 1 out. So from 3 fives, 1 5 out. Now this is 4th root. So from 4 equal factors. So from 4 threes, 1 3 out. There's already a 15 here into. Now this is 5th root. The radical sign is 5th root. So from 5 equal factors, 1 out. So 5 twos, 1 2 out. 5 fives are 25 minus 40 plus 3 plus 30. So what is this? 33 and 7. Oh, I don't know. 18. Yeah, 18. So this, yeah, is this okay? Is this clear?
Yes, ma'am, understood.
Good. Okay. All of us understood?
Yes, ma'am.
All right.
Yes, ma'am.
Yes, ma'am.
Yes.
Very nice. Okay. So how do we understand this question actually? So this is minus 2 into cube root of 5 into cube root of 5 into 3 into cube root of 5 into 4 into cube root of 5. See, like if you have AB into CD into EF, what's the meaning? It's A into B. AB means A into B. Into CD means C into D. Into EF means E into F. Similarly, 2, okay, minus 2 cube root of 5 means minus 2 into cube root of 5. 3 cube root of 5 means 3 into cube root of 5. So it's multiplication everywhere. So this is the given question. So since it's multiplication everywhere, I've multiplied -2, 3, and 4. -2, 3, and 4. And then cube root of 5 into cube root of 5 into cube root of 5 into cube root of 5. -2 into 3 into 4. Cube root of 5 into cube root of 5 into cube root of 5 into cube root of 5. Is the first step understood? So next, 4 3s are 12, 2s are 24, -24, -24. And cube root of, you can write, see, you can, like, when you have square root of 2 into square root of 3, you can write it as square root of 6. You can multiply and write it as square root of 6. When the radical sign is the same, you can perform multiplication. So here we have the same radical sign, cube root everywhere. So you can multiply them, meaning you can write the numbers under the same cube root. So this can be written as cube root of 5 into 5 into 5 into 5.
Yes,
Now
ma'am.
so from 3 equal factors, from 3 5s, 1 5 out. So -24 into 5, from 3 5s, 1 5 out. And this 5 remains under the cube root. Now 24 into 5 is 120, so -120 cube root of 5. So first we multiply the numbers -2, 3, and 4, for which we get 24. And then this into this into this into this. You can take one cube root symbol and multiply all the 5s under that. So cube root of 4 5s, 5 into 5 into 5 into 5. Now under the cube root, from 3 equal primes, you can bring, or from 3 equal factors, you can bring 1 out. So from 3 5s, 1 5 out. And this 5 remains under the cube root, under the cube root. So now -24 into 5 is -120 cube root of 5. Any questions?
No, ma'am.
Okay. Yeah, you can 10, 10, 11, and 12. This situation has been explained to you during the, I think, introduction or the initial classes of this chapter, number systems. So you just use your classwork, recall, and try to do this yourself. We'll discuss this on Tuesday, the next class on Tuesday. I'm talking about 9, not 9, 1 second, 9 we finished. So 10, 11, and 12. All similar question. 10, 11, 12, similar questions. Open your classwork, find the question similar to this, go through that, understand, and then try to do these. Yeah, these questions are of 8th standard. This is just to recall. You should help yourself with all this. Yeah. Yeah, go through this one. Ask me if you have any questions.
No doubts, ma'am. No doubts, ma'am.
Nice.
No doubts, ma'am.
Okay.
No doubt, ma'am.
All right. So we know when the base is raised to many powers, you have to multiply the power. So you can simplify. This is nothing but 6 to the power 2 into minus 3 by 2. So you can cancel the 2 and 2. So 6 to the power minus 3. 6 to the power minus 3 is 1 by 6 to the power 3. 6 to the power minus 3, when the power is negative, if you want to make it positive, the power is negative. If you want to make it positive, take the reciprocal of the base. The power is negative. If you want to make it positive, by the rule or the law of exponents, if you want to write minus 3 as plus 3, then take the reciprocal of the base. The base is 6, meaning 6 by 1. It becomes 1 by 6. 6 to the power minus 3. You don't want minus 3. You want plus 3. So if you write the power minus 3 as plus 3, take the reciprocal of the base. The base now is 6 by 1. 6 means 6 by 1. You should write it as 1 by 6. That's how we get 1 by 6 the whole cube. Supposing you have 3 by 4, the whole power minus 7. This is the same as, if you want to write minus 7 as plus 7, then you must write 3 by 4 as 4 by 3. These two have the same value. They have the same value. Minus 7 is written as plus 7. Then the base 3 by 4 should be written as its reciprocal 4 by 3. You should not take the reciprocal of the power. Power always negative. For the power, you can only change the signs, plus to minus or minus to plus for the power. Base, you should not change the sign. Base, you must only take the reciprocal. So supposing you had minus 3 by 4, the whole power minus 6. Base, you must take only reciprocal. So the reciprocal of minus 3 by 4 is minus 4 by 3. Sign you should not change, only reciprocal. So minus 3 by 4 is minus 4 by 3. The power minus 6 will become plus 6. Now these two are equal. Both are the same. Another example, 3 by 5. Supposing you have a positive power, 6, but you want to write a negative power. Okay, you want to take a negative power. So you want to write 6 as minus 6. Then you must write 3 by 5 as 5 by 3. Reciprocal of the base, a negative of the power. This way, the two expressions will have the same value. These two are equal. 3 by 5, 5 by 3. Reciprocal of the base. Plus 6, minus 6. Negative of the power. The two expressions have the same value. So here, 6 to the power minus 3. 6 to the power minus 3. Okay, you don't want minus 3, you want plus 3. So minus 3 becomes plus 3, and the base 6 becomes, the base is 6 by 1, it should be written as 1 by 6. So 1 by 6 to the power 3, which is 1 by 6 into 1 by 6 into 1 by 6, which is 1 by 260. Yeah, what is 8? Can we write this 2 cubed? And there's already that power 1 by 3. So into 1 by 3 plus 27 is what? There's already the power 1 by 3. The whole raised to the power 3, the whole raised to the power 1 by 4. So 3 and 3 gets cancelled, 3 gets cancelled. So we have 5, and in the bracket we have 2 to the power 1, which is 2, 3 to the power 1, which is 3. So 2 plus 3, 5. 2 plus 3, 5. And 5 to the power 3. See this bracket, power 3, right? The whole power 1 by 4. So now this is nothing but 5 to the power 1 into 5 to the power 3. See, it's multiplication. 5 to the power 1 into 5 to the power 3. So like bases are same and it's multiplication. So we need to add the powers. 5. 1 second. Okay, so here 5 means 5 to the power 1. It's multiplication, add the powers 1 plus 3. The whole power 1 by 4. So this is 5 to the power 4 into 1 by 4. Because we know when the base is raised to many powers, we have to multiply the powers. 4 gets cancelled and 5 to the power 1, which is 5. Okay, do it again. Open the square bracket. Write the 5. Open the simple bracket. 8 is 2 cubed. But there's already this power 1 by 3. So multiply the powers. Plus 27 is 3 cubed. But there's already that power 1 by 3. So multiply the powers. Close the simple bracket. You can see the power 3. Write that. Close the square bracket and you can see the power 1 by 4. Next. Cancels. Open the square bracket. 5. Simple bracket. 2 to the power 1. 3 to the power 1. So 2 plus 3 it is 5. 2 plus 3, 5. Okay, and this simple bracket, close the simple bracket and you can see the power 3. Put that. Close the square bracket. And outside you have the power 1 by 4. Now this is 5 into 5 cubed. 5 into 5 cubed. Bases are same. It's multiplication. Add the powers. 5 to the power 4. 5 to the power 4. And this power 1 by 4. Multiply the powers. 5 to the power 1, which is 5. All right. Any questions, children?
No one.
Okay.
No one.
Yeah, tell me. How do you do this one? Open square bracket. 9. Simple bracket.
8 square.
64 is what?
8 square.
A better way of writing? Using 4. 4 into 4, 16. 16 4s are 64.
64 is 8 square, miss.
8 square, correct. But if you write 8 square, it's not going to help you because 8 square into 1 by 3, no? Then again, you should give one more step. 8, you must write it as 2 cubed. Okay, fine. Let me go. I'll just tell you the difference. See here. You'll just need 2 more steps. See, you're saying 64 is 8 square. It's not wrong. You're right. Then into 1 by 3, no? But you can't cancel. So what will happen in the next step? You have to write 8 as 2 cubed. Next step, you must write 8 as 2 cubed. then into 2 into 1 by 3. So 3 and 3 will get cancelled. And 2 square is 4. Instead, you can get this result straight away. How? 64 to the power 1 by 3, no? 4 cubed. 64 is 4 cubed. 4 into 4, 16. 16 4 is 64. 4 into 4, 16. 16 into 4, 64. So if you write it as 4 cubed into 1 by 3, you'll directly get that 4. If you write 8 square, you're not wrong. You can't cancel because you have a 2 and 3, you cannot cancel. So you need to take one more step. You need to write 8 as 2 cubed. 2 into 2 into 2. 2 cubed and then this 2 into 1 by 3. Then 3 and 3 cancels. 2 square is 4. Was that difficult to understand?
No, ma'am.
It is easy to understand, miss.
Very good. So you can choose 8 square or 4 cubed, but 4 cubed, you'll get it straight away. You don't need that extra step. So open the square bracket, write 9, open the simple bracket, write 64 as 4 cubed, but there's already that power 1 by 3, so into 1 by 3, the plus sign. 125 is 5 cubed, 5 into 5, 25, into 5, 125. But the power 1 by 3 there, so into 1 by 3. Now close the simple bracket, and when you close the simple bracket, you can see the power 3, so put that. Then close the square bracket and you can see the power 1 by 4. Now 3, 3, 3, 3 cancels. Now again open the square bracket, write 9. Open the simple bracket, 4 plus 5 it is. Because 4 to the power 1 is 4, 5 to the power 1 is 5. 4 plus 5, 9. 4 to the power 1, 4. 5 to the power 1, 5. 4 plus 5, 9. And you can see the simple bracket simplifies to 9. And that simple bracket is raised to the power 3. The answer in the simple bracket is 9. And that 9 is raised to the power 3. Watch that carefully. This one is 9 now. 9 to the power 3. Then close the simple bracket, close the square bracket. Raised to the power 1 by 4. Now this is 9 to the power 1 into 9 to the power 3. 1 plus 3, 4. 9 to the power 4. 1 plus 3, 4. 9 to the power 4 into 1 by 4. So 9 to the power 1, which is 9. That's what you see here. Yeah. Tell me for this one. 27 can be written as?
Three cubed.
3 cubed. 3 cubed. Into minus 1 by 3. Into, again 3 cubed. Into minus 1 by 3. Into square bracket. 3 cubed into 1 by 3 minus 3 cubed into 2 by 3. 27 everywhere is written as 3 cubed. And since there's already a power, multiply the powers into minus 1 by 3, into minus 1 by 3, into 1 by 3, and into 2 by 3. Now 3, 3, 3, 3, 3, 3, 3, 3 cancels. 3 to the power minus 1 into 3 to the power minus 1 into, you can change the simple square bracket to a simple bracket, or you continue to write the square bracket. Anything is fine. 3 to the power 1 is 3 minus 3 squared is 9. 3 to the power 1 is 3 and 3 squared is 9. And we just learned how to make a negative power positive. You want to write minus 1 as plus 1. So the base 3 should be written as 1 by 3. So 3 to the power minus 1 is equal to minus 1. You want to write it as plus 1. Then the base which is 3 by 1. The base is 3. That is 3 by 1. Should be written as 1 by 3. So 1 by 3 to the power 1 is nothing but 1 by 3 because to the power 1, right? So it's just 1 by 3. So 3 to the power minus 1 is nothing but 1 by 3. I'll repeat that. 3 to the power minus 1. You don't want the negative power. You want it positive. Okay, so we'll write a positive 1. So minus 1, you have written it as plus 1. The power minus 1 is written as plus 1. Then the base 3 by 1 should be written as its reciprocal 1 by 3. Base always reciprocal. Power negative. Change the signs. So 1 by 3 to the power 1 is nothing but 1 by 3. So you can write them directly. Yeah, so I was telling you 3 to the power minus 1, just write it as 1 by 3. Into, again, 1 by 3. Into 3 minus 9 is minus 6. So simplify 3 ones are 3 twos are. So the answer is minus 2 by 3. Because 1 into 1 into 2. 1 into 1 into minus 2. So minus 2 by 3 into 1, 3. So minus 2 by 3. Remember 3 to the power minus 1 is 1 by 3. So that you should not get confused or you should not forget that. So 3 to the power minus 1 is 1 by 3. This 3 to the power minus 1 is 1 by 3. This is 3 to the power 1, which is 3. 3 squared is 9. 3 minus 9 is minus 6. Then cancel. 3 ones are 3 twos are. Any questions, children?
No, ma'am.
Okay. Class, use the emoji. Raise your hand.
Ma'am.
Use the raise hand. Use the raise hand option and raise your hand.
Ma'am,
Gayatri. No problem. You're there. No problem. Okay, fine. Anyways, you're talking to me, so you're there. No problem. You can figure it out later by yourself. It's right on top of the meeting window.
Okay, ma'am.
Gayatri, Aishwarya, Sai Smriti, Yarni, Surya, Lakshana, Naved, Netra, Sai Sudesh, Hari, Darshan, and Harsha. Harsha, are you there? Are you there, Harsha? Yeah. Just pick something else. Yeah, let's try questions like this. Look at this one. Now, before we, understand the steps to answer these questions, let's understand one thing. Now, if you have, say, this expression 5 to the power n plus 4, then it should have earlier looked like this, right? The previous step should have been 5 to the power n into 5 to the power 4, correct? See, now if you have an expression 5 to the power n plus 4, what is its earlier step? It should have been 5 to the power n into 5 to the power 4, right? That's why bases are same. That's why bases are same multiplication. You add the powers and you write 5 to the power n plus 4. Now, if you have 5 to the power x plus y plus z, then the earlier step should have been 5 to the power x into 5 to the power y into 5 to the power z. Because bases are same, 5, 5, 5, it's multiplication. So you add the powers x plus y plus z. Understand the earlier step? Now, supposing you have 5 to the power x minus y plus 4, or say minus 4. Then the earlier step should have been 5 to the power x into 5 to the power minus y into 5 to the power minus 4. Bases are same, 5, 5, 5. It's multiplication. So we have to add the powers. So when you add the powers, you'll get x plus minus 5 plus minus 4. So x plus minus 5 is minus y. X plus minus y, I think by mistake I said 5, I think. So x plus minus y is x minus y. And plus of minus 4 is minus 4. The earlier step for this expression is this. Right, children?
Yes, ma'am.
Okay.
Yes, ma'am.
That's one thing. And supposing, you have 5 to the power 50 plus 5 to the power, say, 48. Okay, now, if I take out, now you cannot use any law of exponents here because bases are same, but it's addition. When bases are same and it's multiplication, you can add the powers. When bases are same and it's multiplication, then you can add the powers. Here bases are same and it's addition. You cannot add the powers. You cannot use the law of exponents here. Bases are same, but it's addition. It's not multiplication. So you cannot add the powers. So how do you simplify? If you have 5 to the power 50 plus 5 to the power 48, what do you do? So take out common. Take out common. So you can take out 5 to the power 50 common or 5 to the power 48 common. Supposing we take the least power common, 5 to the power 48 common. Open bracket. In such cases, you will write the same base. Write the same base. You will only write a different power. Now 5 to the power 48. 1 second. Fill in the blanks. If you take 5 to the power 48 common, 5 to the power 48 into 5 to the power what will give you 5 to the power 50. Fill in the box. You don't need this long to answer this question. 5 to the power 48 into 5 to the power what will give you 5 to the power 50?
5 to the power 2.
2.
5 to the power 2. Why? Because bases are same and it's multiplication. So you have to add the powers. 48 plus what is 50? 2. So here we have 5 to the power 2. Because when you multiply these two, 5 to the power 48 into 5 to the power 2, you get 5 to the power 50. Plus 5 to the power 48 into what? Into 5 to the power what will give you 5 to the power 48 itself.
1, ma'am.
1 will become 48 plus 1, 49. Five to the power 48 into 5 to the power what will give you 5 to the power 48 itself.
Ma'am, minus 48?
No, that will become 5 to the power 48 into 5 to the power minus 48 will be 5 to the power 48 minus 48. It will be 5 to the power 0. So 5 to the power 48 into 5 to the power 0 is 5 to the power 48. Because anything to the power 0 is 1, no? So 5 to the power 48 into 1 is 5 to the power 48. I'll clear the screen and ask you again. So like 3 to the power 27 into 3 to the power what will give us 3 to the power 25. Yeah.
Minus 2.
Minus 2. Minus 2. Bases are same. It's multiplication. So we need to add the powers 27 plus minus 2. So 27 minus 2, 25. Correct. 3 to the power 30 into 3 to the power what will give us 3 to the power 30?
30.
1. Sorry, 0, 0.
0, ma'am.
0. 3 to the power 41 into 3 to the power what will give us 3 to the power 45?
4.
4.
4, ma'am.
4. What's the earliest step for this? What is the earliest step? 2 to the power?
2n.
2n
Into 2 to the
into?
power 5.
Very good. Into 2 to the power minus 5. The previous step. 2 to the power 2n into 2 to the power minus 5. Okay. So with this pre-knowledge, I think it will be easy to understand.
Also be in division, right, ma'am? 2 to the
No,
power 2.
you can, but we'll not do it like that here. You can. You can. So now look at this one. So 7 to the power n plus 2. The earliest step will be 7 to the power n into 7 to the power 2. Correct? Don't go ahead of me. We'll see the same thing at the same time. 7 to the power n plus 2. The earliest step. 7 to the power n into 7 to the power 2. Bases are same, multiplication. So when you add the powers, you'll get 7 to the power n plus 2. Minus this 3, 7 to the power n plus 1 is 7 to the power n into 7 to the power 1. Divided by 20 into 7 to the power n. Nothing can be done as it is. Minus 2 into 7 to the power n as it is. Now here, this 7 to the power n, 7 squared is 49. 3 into 7 is 21. 3 into 7 is 21. And the 7 to the power n. You can write anything first. You can write 21 into, you can write anything first. You can write 21 into 7 to the power n also. The same. Here also, you can write 49 first and then 7 to the power n. Anything. 7 squared is 49 and 7 to the power n. 3 7 21 and 7 to the power n. Denominator as it is. Now in the numerator, see, this is one part. This is the second part separated by a minus sign. In the denominator, one part, other part separated by a minus sign. Now in the numerator, this part and this part have 7 to the power n common. So bring it out. In the numerator, the first part and the second part have 7 to the power n in common. Bring it out. So in the bracket, you will have, see, this is common. This is outside common. So in the bracket, you will have 49 minus 21 in the bracket. In the same way, in the denominator, these two parts have 7 to the power n common. 7 to the power n common. Write it out. So in the bracket, you would have 20 minus 2. 20 minus 2. Now 7 to the power n in the numerator and denominator gets cancelled. When you simplify the brackets, 49 minus 21, 28, 20 minus 2, 18. Cancel using the tables of 2, you get 14 by 9. So the value of this expression is 14 by 9. Got it, children?
Yes, ma'am.
Okay.
Yes, ma'am.
Yes, ma'am.
Yeah, we'll
Yes,
do one
ma'am.
more like this. Great. See here. Similar. 5 to the power n plus 2 is 5 to the power n into 5 to the power 2. Because bases are same, it's multiplication, so you add the powers n plus 2. N plus 2. Right? Then here, 5 to the power n plus, the 6 as it is, 6 as it is. 5 to the power n plus 1 is 5 to the power n into 5 to the power 1. Because bases are same. 5, 5, it's multiplication. So when you add the powers, n plus 1, here n plus 1. So we are writing the earlier step. 13 as it is, 5 to the power n, it's simple, right? So you write it as it is. And minus 2, 5 to the power n plus 1. So it's 5 to the power n into 5 to the power 1. Okay. Next, 5 squared is 25. This 5 to the power n as it is. 6 5s are 30. 5 to the power n as it is. I told you can write anything first, children. You can write 25 first and then 5 to the power n. It's multiplication, right? So it's commutative. You can write it in any order. 5 to the power n, 5 squared is 25. 6 5s are 30. 5 to the power n. 2 5s are 10. 5 to the power n. And here as it is, 13 into 5 to the power n. So in the numerator, one part, other part. Denominator, one part, other part. Both the parts separated by a minus sign in the numerator and denominator. See, minus plus sign, that is not a criteria. I'm just mentioning the sign. They are separated by here, that's all. So in the numerator, between the two parts, we have 5 to the power n common. 5 to the power n common. So write it out. Okay, so when you bring out 5 to the power n common, 5 to the power n common, in the bracket, you should write 25 minus 30. 25 minus 30 in the bracket. Similarly, in the denominator, we have 5 to the power n common. Write it out. And in the bracket, you would have 13 minus 10. Now, in the numerator and denominator, 5 to the power n gets cancelled. Simplifying the brackets, 25 minus 30 is minus 5. 13 minus 10 is 3. So the answer is minus 5 by 3. All right.
Yes, ma'am.
Yes, ma'am.
Okay. Now here also, look at the powers of 2 we have. We have 30, 29, 28, 31, 30, 29. So among the powers, which is the least power? Among the powers, which is the least power?
28.
Yeah. So take out 2 to the power 28 common in both the numerator and the denominator. Take out 2 to the power 28 common in both the numerator and the denominator. Whichever is the least power, on the whole. So comparing everything, the least power is 2 to the power 28. Take out that common in the numerator and the denominator. Now, 2 to the power 28 into 2 to the power what will give you the result 2 to the power 30, because the first term is 2 to the power 30, right?
2 to the power 2.
2 to the power 2. So that's what you should write here, 2 to the power 2. Because 2 to the power 28 into 2 square is 2 to the power 30, the first term here. The second term you should get is 2 to the power 29. You must get 2 to the power 29. And outside we have 2 to the power 28. So 2 to the power 28 into what? Into 2 to the power 1 will give you 2 to the power 29. Okay. So plus 2 to the power 1 plus we have 2 to the power 28 outside. So 2 to the power 28 into 2 to the power what will give you 2 to the power 28 itself?
0.
0. So 2 to the power 0. In the denominator, 2 to the power 28 into what? Will give you 2 to the power 31.
2 to the power 3.
3. 2 to the power 28 into what will give you 2 to the power 30.
2. 2 to the power 2.
Minus 2 to the power 28 into what? 2 to the power 28 into 2 to the power what will give you 2 to the power 29.
2 to the power 1.
1, ma'am.
2 to the power 1. 2 to the power 1. So that's what you have here. That's what you have here. Now 2 to the power 28 in the numerator and the same thing. Okay, same thing. And the numerator and denominator gets cancelled. So 2 squared is 4. 2 to the power 1 is 2. 2 to the power 0 is 1. 2 cubed is 8. This is 4. This is 2. Now on simplifying this, we get 7 by 10. Let's try one more like this. So look at the powers and which is the smallest of all the powers?
28. 3 to the power 28.
3 to the power 28. So we'll take out 3 to the power 28 common in the numerator and the denominator. Yeah. So 3 to the power 28 into 3. See, everywhere you will get 3 only. You should put 3 only. Powers will be different. 3 plus 3 minus 3. Because we have 3 terms, no? We have taken out 3 to the power 28 common in the numerator and denominator. Now in the bracket, both in the numerator and denominator, we have to write 3 terms. Okay, so for all the 3, the base will be 3. You should decide the power. So now 3 to the power 28 into 3 to the power what will give you 3 to the power 30?
3 to the power 2. 3 square.
3 to the power. Yeah, next for the next one, 3 to the power
1.
next
0.
0. Then below
3 to the power 3. 2. 1.
so 3 this into this will give you the first term. This into this will give you the second term. This into this will give you the third term. This is the first term, second term, third term. This into this will give you this first term in the denominator, second term in the denominator. This into this, the third term in the denominator. So now cancels. 3 squared is 9 plus 3 plus 1 over 3 cubed is 27 plus 9 minus 3. That simplifies to 13 by 33. All right.
Yes, ma'am.
Yeah. I'll just stop the recording and give you the further instructions.